Hi, welcome to the next video on LabVIEW. Having done with few basic experiments like the usage of the mathematical operations, you're familiar with the usage of the numeric data, you know the differences between the graphs and the chart. Now let me introduce to the generation of a signal. If a signal has to be generated, the parameters to be specified to the generation of a signal would be like the type of a signal, amplitude, phase, frequency, offset, etc. So which you have done using this you have done in a AD kit, that is a waveform generation in a AD kit. So these parameters will be specified now to generate a signal. To go generate a signal, you can just go to the block diagram of a LabVIEW, right click on the block diagram panel. You could go to express, then input. Under that you will have a simulate a signal block. You can place it on the block diagram panel. So I have done that over here. So where I have connected the input parameters also, I'll just show you the simulations of this. Let me go in detail with the block diagram. That is with the block of simulate signal. If you just double click on this block, you can see the signal type to be generated. I have choose by default it is sine. You can just generate a square wave, triangular, sawtooth, or even a DC signal similar to that which you have used with waveform generation of AD kit. The frequency is 10.1 Hertz, which is a default value. Once again, the phase is 0, amplitude is 1, and the offset is 0. So these are the default values. Even if you don't give any input parameters, so block considers these values for the simulation purpose. Next, if you are generating a square wave, you could give duty cycles of desired data. So next, one more parameter which we are more interested over here is the timing parameters, which is samples per second, which is expressed in Hertz, for a clear visibility of the wave, or to get a wave to be displayed in a smooth manner. That is, to give the smooth display of the wave, let this be 100 times the frequency you choose. Okay, so you can, these are the default values. So now I'll just go generate a sine wave itself. So I'll just click on OK. I don't want the default values to be as my input parameters, so I have given the input parameters amplitude, frequency, offset, and the phase, which is in degrees. The signal will be displayed on an oscilloscope over here, so which is a waveform graph. One difference from the AD kit which you have used to this simulate signal block is error in a communication system. So signal generation is just the only it is not just the only block. So we'll have modulation, demodulators, oscillators, etc. Error in specifies if there is any error in the previous block of a communication system, that will be fed as input to this terminal. So if this block itself is generating any error, so that could be taken out from the error out terminal. We have one more parameter which is used to reset the signal. So now I'll run the wave, continuously run this code, and I'll give the amplitude to be as 1 volt. Let the frequency be 2000 Hertz. Coming up with the adjustment of the axis on x-axis. As soon as you pick up a graph, you will have the axis from 0 to 100. So you will have to adjust the x-axis, that is a time parameter, which will be according to the frequency that is specified. So to adjust the x-axis, or to give the x-axis parameters, the number of cycles you wish to see on the scope will be multiplied by the inverse of the frequency. So I have frequency 2000 Hertz. I want to see 4 cycles where the time comes to be around 2 milliseconds. So amplitude is 1 volt. You can just vary the amplitude and see with the adjustment of the scale. So where I have given auto scale on y-axis, as I vary the amplitude, the axis gets adjusted, or it will be auto scaled. You can see the variation over here, even with the frequency use. So only 2 cycles or 3 cycles have to be displayed over here, for which accordingly the time comes to be around 2 milliseconds. Coming up with the phase value. A normal sine wave which will be of 0 degree phase, the phase parameter is the default value which was chosen. Now let me give it around 50 degree. So you could see the phase variation at the time instant 0. Similarly, you can give the offset value as 1 volt. So wave will be shifted above by 1 volt. Now let me say if I want to generate if I need to generate a square wave or a triangular wave, so that you could go over here, select the signal type to be as a square or a triangular wave. Let me go with the triangular wave. So click on select triangle and click on OK. Run. Yes, you could see a triangular wave, so which is of amplitude 2.17 volts and with the offset 1 volt. So where the frequency is around 2000 Hertz. Let me give it as 2000 Hertz. So once again you could see the variation with the usage of the phase. That is, if I go with 90 degree phase, so you will have exactly the peak which will be at 0 time instant. Now if you want to generate a cosine wave, so having a look at this signal type, you don't have a cosine wave over here. To generate a cosine wave, you could go use the sine block itself, okay, sine, but give the phase to be as 90 degree, which generates the cosine wave. And continuously. So this is with the cosine wave, which is of 2000 Hertz, 2.17 volt with 1 volt DC offset. So this is with the generation of a signal by using a simulate signal block. In the next video, we shall consider 2 signals, 2 sine waves. We shall try to multiply which comes to be a modulated signal, a DSBSC signal or a standard AM signal, and we shall observe the variations as well as the spectrum in the next video. So thank you.